Okay, now we're at part 4 now. We talk about redox reaction. We're going to look at the reaction itself and see how we can identify if things are redox. Okay? What are redox reaction? Obviously, as I said just now, it means that it's a reaction. Okay, a reaction that involves both oxidation and reduction. Okay, so now let's identify which of the following are redox. So first example, we can try. Okay, let's look at this. Let me get the photo there. Okay, let's get this down again so we can have some reference. Okay, let's put it down. Now, so nickel to Na2 plus and Sn2 plus to Sn. So you can see, let's look at element to element. Ni initial oxidation state is 0 because it's element on its own. Or nickel attached to nothing else. Sn2 plus, this is actually tin. So oxidation state of a simple ion equals to the charge. This is considered a simple ion. It's an element with a charge only. So this oxidation state is plus 2. Now, Ni, charge. So this is plus 2. Sn here, element on its own, so it's 0. So now we map out element to element. So for Ni, it becomes Ni2 plus. So this is a plus in oxidation state. Okay, so you can see it's a plus in oxidation state. In actual fact, it's plus how many? It's a plus 2. The change is a 0 to a plus 2. So the change is plus 2. In this case, this is an oxidation. Okay, next one we look at Sn. It changes from a plus 2 to 0. So it's actually a minus in oxidation state. Minus how many? Minus 2. So this is actually a reduction. So obviously there's an oxidation, there's a reduction. So yes, this is a redox reaction. Let's try another one. Okay, iron, element on its own, oxidation state 0. Chlorine, element on its own again, attached to no other element. So oxidation state 0. FeCl3. Okay, Cl has oxidation state of minus 1. Actually, you can just look at the valency. Iron, you're not sure. Okay, so actually what you can do is at this point, you can do some simple maths again. So I want to find the FeCl3 oxidation state of Fe. Put it as X. For Cl, I know it's 3 Cl minuses. Okay, so let's do some simple calculation. 1x plus 3 minus 1 overall is a 0. So realize X has oxidation state of plus 3. So this Fe here is a plus 3. Now, let's look at each element. Fe, from 0, it becomes plus 3. So this oxidation state, the change in oxidation state, and let's put a triangle, change in oxidation state is actually a plus 3. So if the change is a positive change, plus 3, that means this is a oxidation. Okay? If it changes from 0 to minus 1, you can see for chlorine in this case here, 0 to minus 1. So this is the change in oxidation state is considered a minus 1. So therefore this is a reduction. So is this redox? Answer is yes. So realize what I do is I tend to look at the element one by one on its own and come to a conclusion about its oxidation state before I go on to talk about whether is it a redox reaction. Okay, let's look at this, the next one. This is slightly more complex, but generally is if you follow the same steps, it will be the same. Mg oxidation state, in this case MgO. Mg is a group 2 metal, so oxidation state plus 2. Oxidation state of oxygen, generally minus 2. H always follows a plus 1. Cl follows a minus 1. You can just look at the valency actually. MgCl2, so this is still a compound, so Mg is still a plus 2. Cl2, okay, chlorine linked to an element, just look at the valency, is a minus 1. H2O, so is bonded, so you just follow the valency. H is a +1. O is a -1. Sorry, -2. So if you look at it carefully, okay, Mg, Mg, +2, +2. Is there a change? Nope, no change. Okay, maybe you look at oxygen. Oxygen from a 2-, down here is also a 2-. Is there a change? Nope. How about H? H from a +1 to a +1 also. So is there a change? Nope. And last one, Cl. From a -1, it still remains as a -1. So is there a redox reaction happening here? Nope, it is no reaction. So we can say that this is not a redox reaction. Okay, now next one we go on to calcium carbonate, reacting to give you calcium oxide and carbon dioxide. Okay, calcium carbonate. Okay, calcium generally a very simple element here, so calcium generally always is a 2+. Carbon, okay, generally tend to follow a +4. Oxygen generally tend to follow a -2. Because these are all in a compound, so you would expect that each of these will look like it. Calcium and calcium oxide in a compound again, so calcium will be a +2. Oxygen, -2. Carbon in a compound, so once again +4. Oxygen in a compound is a -2. So let's look at each element individually. Okay, now, so let's look at each element individually. For calcium, okay, its original oxidation state is a +2. After the reaction, oxidation state is still a +2. So is there a change? No change for calcium. Let's look at carbon. Before reaction is a +4. After reaction, it is still a +4. Change in oxidation state? Nope, no change at all. Oxygen, initially -2. After that, this oxygen here -2, this oxygen here also -2. So is there a change in oxidation state? Nope. So this is not a redox reaction. Let's look at the next one. Nitrogen. Interestingly, this element on its own. Right, let me try to bring down the... Sorry. No, it's here, sorry. Okay, let's try to bring this down so you can have a look. Okay, now. So you can see nitrogen, element on its own, oxidation state, 0. Hydrogen, oxidation state, also 0 because it's element on its own. Now, when it forms a compound like this is an interesting one here. Generally, hydrogen tends to follow a charge of, oxidation state of +1. So in the end, we have to do some simple calculation. So NH3, right, and we do not know the oxidation state, so we put it as X. Hydrogen, we know that oxidation state is a +1. How many of it do we have? We have 3. So we know that X, how many X do we have? 1X plus 3 times +1 overall is equals to a 0 because no charge overall. So X is equals to -3. So oxidation state of nitrogen is a -3. For hydrogen is a +1. So let's see the thing here. Nitrogen, 0 to -3. So this is what's the change in oxidation state? Okay, maybe it's a bit hard to, let me erase this here. Okay, so in this case here, 0 to -3. So this is what's the change? Okay, change in oxidation state for nitrogen is equals to a -3, from 0 to -3. So this is actually a reduction. I'll just put a red. How about hydrogen? So you look at hydrogen, realize from 0 it becomes a +1. So the change in oxidation state is equals to a +1. So this is oxidation. So is this a redox reaction? Answer is yes, it is.